Okay, in this series of videos, we're going to start looking at the Laplace transforms of piecewise continuous functions. Now, since piecewise continuous functions can be neatly expressed in terms of Heaviside functions, we're going to start by looking at some formulas, in fact, three formulas of the Laplace transforms of functions that involve the Heaviside function. You are going to remember that the Heaviside function of t minus a is going to be 0 when t is less than a and 1 when t is greater or equal to a. So we have talked about this in a sequence of videos we've done where we were looking at how to express piecewise continuous functions in terms of the Heaviside function. So this function here is going to look something like this. So I've got these three formulas here. The first one says the Laplace transform of h of t is 1 over s. You're going to notice that this is basically the same as the Laplace transform of 1, and that's because in the domain, in this domain here, h of t is essentially the same as f of t equals to 1. H of t is 1. Okay, then the second formula says that h of t minus a is given by e to the minus as over s. And then the last one, h of t minus a times f of t minus a is given by e to the minus as times f of s, where f of s is just the Laplace transform of f here. So let's look at the proof of 2. If we can prove 2, then you can see that if you just let a equal to 0 here, then 1 follows. So the Laplace transform of h of t minus a using the definition of the Laplace transform, going to be the integral from 0 to infinity h of t minus a e to the minus st dt. Now in terms of this definition here, so remember for Laplace transform we're interested in this interval here. So this is going to be the integral from 0 to a, but in that interval h is 0. So that is going to be the first integral, and then the integral from 0 to infinity. In that interval h is 1. Okay, so since the first integral is just going to vanish, so all we're dealing with here is the integral from a to infinity of e to the minus st. This, of course, we can integrate straight away. It's going to be that. So evaluated between a and infinity. In the limit as t goes to infinity, this thing goes to 0. This thing here. And then, of course, when t is equal to a, this thing is going to be negative as. And then if we open the brackets, this is going to give us the required result. So that is the first one. Then we are going to prove the second one, or if you like, the last one here. So proof of 3. So this time we've got the Laplace transform of h of t minus a times f of t minus a. Again, plugging this into this integral, h of t minus a f of t minus a e to the minus st dt. And then again, between 0 and a, this is going to be equal to 0. So we're going to have the integral from 0 to a, 0 times f of t minus a e to the minus st dt. Then between a and infinity, this is going to be 1. So we're just going to have f of t minus a e to the minus st dt. So the first term vanishes. The second term, integral of f of t minus a e to the minus st dt. Now, what we're going to do here is we are going to make a substitution. So we are going to let u be equal to t minus a. Then du is simply going to be dt. And t is going to be u plus a. When t is equal to a, u is going to be 0. As t goes to infinity, u is also going to go to infinity. So if we denote this I, so our integral is now going to be the integral from 0 to infinity. F of t minus a is going to be f of u e to the minus s times t. T is u plus a from here, and du is dt. Then the exponential term f of u we can write as e to the minus su times e to the minus as du. Now, since this is an integral of u, this is constant, so we can factor it out. 0 to infinity f of u e to the minus. Okay, however, this is just the Laplace transform of f, because remember, the u is just a dummy variable. It could be u, it could be t, could be anything else, well, except the letter s in this case. So this is e to the minus as times the Laplace transform of f, which completes that derivation. Alright, so thanks for watching this. In the next video, we're now going to start looking at how some numerical examples of how do we find the Laplace transforms of piecewise continuous functions, of course with the help of the Heaviside function. Okay, thank you for watching. We do implore you to press the subscribe button. If you've got any questions, you can post them in the comment section. Thank you.